Our next speaker, Steve Klabnik. Welcome him.
Hi, everybody. I'm Steve. Thank you so much for having me back. This is my second Rails Club. I was here in 2012, and I had a wonderful time then. And this is a much fancier building now, so it seems like you all have been growing since then. So it's cool. I'm here today to give you a talk called Exploring Ruby Through Rust. So we're going to talk about a lot of stuff. But first, so a lot of people ask me why I like Rust. And I got into this joke. They're like, Steve, you've been programming in Ruby for a really long time. So what's the deal? Like, why do you like Rust? And I started telling people that it's because they start with RU. And so I'm only going to program in programming languages that start with RU from now on. But then when the topic of like whether I was going to come to Rails Club or not came up, they were like, so are you going to have to give the talk in Russian, since that's also a language that starts with RU? So I will not be doing that. I tried to do a little bit of Duolingo. Like when I accepted the invite, I was like, I'm going to do some Duolingo and be totally great at Russian. And then life gets in the way. So I'm sorry, but English today. OK, so this talk is going to be covering a lot of ground. I don't necessarily expect all of you to understand all of it. It's more about the enthusiasm of learning new things, and we're gonna go all over the place. There's probably going to be not a lot of live coding, but like a little bit of like running some programs I wrote earlier, and those are probably going to get messed up. We're just going to have a good time. OK, so Rust is a programming language. I really love Rust. If you have not heard of Rust before, I work at Mozilla, where we're developing this programming language called Rust. We're using it to write a new rendering engine called Servo, and Rust code is now running in Firefox. So kind of the idea is that Firefox is about 4 million lines of C++ code, and C++ is a very dangerous programming language where if you get things wrong, bad things happen. And when you have a program like Firefox, which is used by hundreds of millions of people, when bad things happen, they happen a lot to a lot of people. So it's really, really important that we get it right. But web browsers also need to be very fast. So historically speaking, this idea of safety and speed have been separate. Like you can either be safe and then very slow, or you can be fast and very dangerous. And so Rust is trying to make a language that is both fast and safe. So that's sort of the high-level pitch. I really like Rust a lot. It's totally cool if you don't like Rust. I think that people that gets like, oh, my programming language is better than yours, like I don't really subscribe to that. I think it's kind of silly. I like programming languages and using lots of different programming languages, and you should too. And I don't like all of them, but it just means I use the ones that I like and ignore the ones I don't. So it's cool. This particular talk is actually going to have 3 separate programming languages in it. We're going to talk about Rust, we're going to talk about Ruby, and we're going to talk about C. But mostly having fun. So we're sort of building towards, at the end of my talk, I'm going to show you my side project, which is totally ridiculous and silly. Another reason that I came to Rust, though, and I sort of heard this echoed a little bit kind of in what Mats was saying this morning. So I think it's sort of common for a lot of people that sort of work on programming languages to go through this sort of set of phases. So originally I was working on applications. So I was building Ruby on Rails apps, and I was building PHP apps before that, and I was always working on applications. And then eventually I was like, I use Rails enough that I know all the ways in which it's not good, so I'm going to start making it better by working on it. And so then I got working on writing Ruby gems in general, and then also Rails. So I started working on libraries, and I found that I enjoyed that far more than working on applications. So I started teaching Ruby instead of writing Rails apps, and I started working on Rails instead of writing Rails apps. But then, you work on a library or a framework long enough, and you're like, well, I think that the language that I'm writing this in maybe could be a little bit different. So then you sort of move down the stack again, and you're like, now I'm going to work on programming languages. And then my hobby project is this project called Intermezos, and it is an operating system. So I kind of feel like I'm going down like yet another one on there. And so I think that working on all of these different things are very interesting, and it's a lot of fun. There's sort of different requirements for each one of these, and they all use a different part of my brain. So part of what I want to tell you, I guess, is that I find that not a lot of Rubyists who build applications want to work on Ruby on Rails or work on Ruby. And so part of the message that I want to get across to you today is, if you've ever thought that maybe you could fix Ruby in some way or make it better, or Rails, like, you should try to do so, because it's totally like within your grasp. You can definitely work on these things. But another reason, a thing that's funny about this, is you'll notice that you'll always keep going lower. So like, I never thought that I would have a day job working on a programming language before. And I also never thought I would work for Mozilla before. But now I am. And now I'm going to operating systems. So I've been wondering, like, am I going to start building my own hardware at some point? And then if I like build my own hardware, am I going to start studying theoretical physics, right? Like, there's always a layer below. Like, we talk about programming languages being high level or low level languages. And, people sort of say that the lower levels are harder, but, C programmers still aren't writing assembly code, and assembly programmers aren't like implementing CPUs. And the CPU people, don't necessarily know theoretical physics, or they know some of it, but not like the abstract physics. So there's always a layer below where you're going, and then at the bottom, like, who knows how the world actually works. So we're all just kind of like doing our best. Anyway, there was something that Matt said in the keynote this morning also that I think is very interesting, and it also reminded me of a story. So before I get to some code, I want to share this little story with you. So Matt said that the Ruby core team is working very hard to make you more productive, to make you work less, and to make you happy. And that's what Matt has always said about Ruby. It's about making programmers happy. And Ruby has made me incredibly happy over the years. I like to joke that I have a Ruby tattooed on my body. Like, that's how much I love Ruby. It's like permanently on me. I also have a Perl camel, because I used Perl before Ruby. I do not have a Rust tattoo yet. We'll see. But this also reminded me, so earlier today, in the Rust world, we have this thing called the RFC process. So we talk about how we're going to modify the language in the future and submit these kind of changes to the language. And so just last night, due to the time zone shifts, it's funny being over here, because my old evening is my morning. So like, when I was walking back home from the bar last night, I found that my coworkers had posted this new thing, and then there's tons of Hacker News comments, and so I stayed up too late reading these things. But there's a new RFC for the roadmap about what we're going to do in Rust in the next year, and I thought that it does not quite surprise me that we're actually saying the same things that Matt is saying about the Ruby core team. So this year's focus is on improving Rust's productivity while retaining its emphasis on fast, reliable code. And so I think that this is one of the things that that I have to bring to Rust, is that while Rust is a low-level programming language, people that do low-level programming often think that their lives have to be terrible, because low-level programming languages have often been really hard to use. And so I've tried to bring the Ruby mentality that Matt's taught us about, like, programming languages should make you happy. And I'm like, no, just because it's a programming language that's low level does not mean that it does not have to make you happy. Like, you can enjoy doing this kind of work. And so I thought it was interesting that we're sort of saying the same thing. Like, it's about productivity, and that's kind of cool. And it also reminded me, the last part of this story, a long time ago, so Akira is speaking after me, but back in 2013, I heard him give a conference talk where he talked about the etymology. So, Matsuda and Matsumoto both share this kanji from Matsu, which is where Mats comes from. And so he said, Mats and I both share the Mats in our names, so I'm also sort of a Mats, but like, please call me Akira, not Mats. So I was thinking, when I was hearing Matt speak this morning, I was like, now that I work on a programming language, like, in some ways I'm bringing Mats to Ruby, but I'm definitely not a Mats. So anyway, okay. I want to show you a little example of what Rust looks like and compare it to Ruby. And then we're going to talk about why they end up being so different from each other. So Rails has this method that they add to Ruby in active support called string blank. And what this method does is, if all of the characters in the string are white space, then it returns true. And if any of the characters are not white space, it returns false. So the implementation in Rails is this one-liner. It looks like this. So this is using the Unicode-aware regular expression matchers, so that it's not just Latin characters. But if all of them match the Unicode space classifier, then you know this is blank. So in this case, this is going to return false, obviously, because that's not blank. And so it's a one-liner in Ruby, and it kind of looks like this. So I have a Rust file, so .rs is the name of Rust files, and it's also the TLD of Serbia, so I've been registering lots of websites on like weird Serbian registrars to get .rs domains. But I have this chars.rs file, so I'm going to show you what some Rust looks like. So, okay, let's make this a little bigger. And is it better with the syntax on or off? Okay. You never know with projectors and the color scheme and stuff whether it's going to work, so we'll leave the syntax highlighting on. So this is that implementation, although it's a full program in Rust. So the first thing, I'm going to skip this stuff up the top here, but you'll notice we have a fn main. So in Rust, we use the fn keyword rather than def to define functions, and main is where your program starts executing. So this is sort of the beginning of this little script. There's this let s equals string from. Let is how you introduce new variables. So we have this extra keyword, but that also gives us some more powers with pattern matching that I won't go into right now. But this creates a new string from this string literal. I won't get into the difference between capital S string and string literals because this is not really an intro to Rust talk. But even though it looks a little weird to call a string method on a string, just don't worry about it, it's fine. And so then there's a method that I added called isBlank, so I can print out with println is s blank, and then there's these little pinchers. It's sort of like the Ruby string interpolation, but the only difference is in Ruby you would have the little that there, right? So we just don't have that. We just have the pinchers. And then printing out the value if it's blank or not. So this would originally print out false and then true, right? So we have an empty string for the second one. The way that this works is a little more complicated than you would have it in Ruby, but it's also weirdly similar. So in Rust, we have this concept called traits. And traits are kind of like a module in Ruby, except for the module wouldn't have any implementations. It would just have the signatures of the functions. And since Ruby does not yet have static typing, that's not quite as useful. But the idea is that this trait we would define called isBlank has one method on it, the isBlank function. And one way in which we're more like Ruby than we are like Python, or more like Python than we are like Ruby, is that self is explicit in Python, but implicit in Ruby. So we have an explicit self, so it's a little more Pythonic. But we have a reference to self as the only argument because it's a method that takes no other arguments and it returns a Boolean for true or false, whether or not it's blank. And then we can implement this trait. So the impl keyword says like implement this particular interface or module onto the string, and then we have the same function signature, but we define the body. And so in this case, the body is a one-liner, and this is like a very Ruby-ish kind of way, even though it's not the way that it's implemented in active support. So we say that, hey, for the string, take all of the characters, and you'll notice we need the parentheses. In Ruby, you can drop them off, but we require them all the time. So let's take all the characters in the string, and then that produces an iterator, which you've used heavily in Ruby, I'm sure. And so there's an iterator called all, and it runs the closure on every single element of the iterator. And if they all return true, then it returns true. And if any of them return false, then it returns false. So here, just like in Ruby, we have the pipes for an argument. So this is a little closure, and it takes one argument C, and we call is whitespace on it. So if all of the characters are whitespace, return true. Otherwise, return false. Incidentally, one of the things I wish I had done so I dropped the curly braces here, but in Rust, we put the curly braces like this, and in Ruby, we put them like this. And I wish I had just like made them the same. This will be like the thing I regret forever in the future, and now the syntax is like stuck that way. But when I switch between the languages, I always screw it up. So, everybody makes mistakes. But anyway, so this is an extremely simple, one-liner, two methods, one on chars and one on all. So we can compile this code. So Rust C is the Rust compiler. So we can call this on chars.rs, and then this will produce a program called chars, and we run it, and we get, the first one is not blank, and the second one is blank. So All right, so we can do the same things in different programming languages. Cool. We can always do the same thing in different programming languages, right? I could have shown you this demo in all kinds of different things. We're going to talk about specifically the differences in how these two things work, but like at the Ruby internals level, and then compare why Rust is like fundamentally different than Ruby, even though that thing feels kind of the same. Almost all of the stuff, when I've done a little bit of hacking on MRI, but not a whole ton. I have a couple patches in, they're almost all documentation. I haven't done that much implementation work, but I've spent a lot of time messing with it. I haven't gotten anything that's like, you know, a patch that is good enough to be accepted, but sometimes I just get bored and I start messing around with the Ruby interpreter. And invariably, the things you end up using are almost always in this file, include Ruby, ruby.h. And .h is a header file in C programs, so it has a lot of definitions in it, and it's used in different places. So to understand what's going on in this particular example in the Ruby interpreter, we need to understand three different things, and that's our object, our basic, and value. The other thing I want to mention here is that I showed you those like levels of abstractions before, right? Like programs, and then libraries, and then languages, and then hardware, and operating systems, and all these things. At some point, like abstractions are fundamentally like lies. Like they're telling you enough of the truth that you can understand what's going on, but they're also leaving a little bit out, right? And that's the problem we get into is when we say abstractions are leaky, it's because the lie breaks through the abstraction, and then we're like, oh no, why didn't I know that? So what I'm going to tell you is like mostly true, but there might be some small details that aren't right. So eventually you will learn those details, but like I'm trying to give you a high level understanding of this. I don't claim that it is perfect. So just to get that out of the way. I've given multiple talks on Ruby internals when like Koichi is in the audience, and there's a very like, oh no, I'm going to say something wrong, and the guy wrote the thing. So anyway, okay, so we're going to talk about our object, our basic, and value. So I'm going to go into my Ruby checkout here. All right, so include Ruby, ruby.h. So first we're going to do our object. So here is the definition of our object in Ruby. And as you might know, or as you would maybe imagine from the name, our object is the C representation of a Ruby object, so like an instance of an object that is in existence. And one of the things that I think is really, really neat about reading Ruby's source code is that you can learn stuff just from reading the data structures themselves. So this is kind of a little complicated, especially if you're not used to writing C code, but let's like break it down. A struct. This is struct our object. So in C, we don't have this classes, we just have structs. And structs basically just have like dumb data in them. But one of the interesting ways in which C is very different than Ruby is that C guarantees the size in bytes of any particular thing that you put inside of a struct. So you can know exactly how much memory it's going to be using, and you can know where it's allocated, and all these details that we don't have to worry about in Ruby, but we can worry about in C. So this struct our object has two different elements. The first one is this other struct, and the second one is this union. I'm going to delete this union for now because it's complicated. We'll get back to it in a second. But inside of our object, the first element is another struct called rbasic, and it has the name of basic. And so rbasic is the type, and then basic is like the name inside the struct. You can imagine it's like @basic in sort of a Ruby class kind of sense. And so rbasic is the basic class that all Ruby instances eventually end up inheriting from at some point. And then we have the second part. So we'll talk about what's in our basic in a second, but the second part is where things get interesting. So the first time I saw this, I went, oh God, what is going on? This is so complicated, but it's not actually that bad. So first of all, unions. So a union is a special construct in C that lets you define a bunch of different options, and then it can just be any one of those options at any particular time. So you have to kind of know which one is accurately here or not. So the union in this case has two things. It has the struct, and then it has this value array thing. So it can be either the struct or this array. And the struct has this 32-bit integer type called numiv, and a pointer to a thing called value that's IV pointer, and then a pointer to void of IV index table. And this is a little complicated, but if you remember, IV is short for instance variable. So this is how Ruby stores instance variables inside of your objects. It has the number of instance variables that you have. It has the pointer to the list of the instance variables. And then it has this table. And I don't remember what the table does exactly. So I need to look into that a little bit more. But the point is that it's got the list of them. So then what about the other part, this array thing? Our object embed len max. So this is an array. And actually, it's defined up here. So there's 3 is the value of our object embed len max. So it took me a little while to figure out. I was like, why are these two things union together? And then I learned this is an optimization. So what happens is if you have 3 or less instance variables in Ruby, it stores them inline inside of your object so that they're faster. But if you have more than 3 instance variables, it has to create this list and do all this other stuff. So just by reading the data structure of our object, I learned a brand new thing about Ruby that I never knew before, that it has an optimization when you have less than 3 instance variables. So you can kind of remember that, like, if I add a 4th instance variable, my Ruby code will get slower. And like, that probably is never going to matter for your application, but it's like fun trivia. I don't know. Maybe I go to different parties than you guys go to. Like, when they trivia at a party, it'll be like, what's the way that you optimize Ruby, objects? Okay, so that's like one interesting thing, and like why I think diving around in the Ruby source code is kind of cool is because you can learn these things by just like reading chunks of it. So, okay, so we have our object, and then we said we're going to talk about our basic. So, so here's our basic. Our basic has 2 things inside of it. It has a value of flags, and then it says I connected to a printer. It says a value of flags and then a value class. So it turns out that our basic is how Ruby stores what class your object is from as well. And so that's kind of cool. So you know that now fundamentally another thing we've sort of learned is a convenient definition for what a class is or an instance is in Ruby. So like, what is a Ruby object? A Ruby object is a pointer to a class and then a list of instance variables. That's it. That's what it is. But we can learn that about Ruby without reading any Ruby code at all, which is kind of, I don't know, it's interesting. I like peering into the details of what's going on here. And then value is something you'll see almost everywhere. Value is kind of what Ruby calls a pointer to any sort of Ruby object, is one sort of way to think about it. And so that's because you can pass Ruby objects around. Matt's mentioned earlier the duck typing principle, right? So we don't care about what type it is. Everything is a value, and then we figure out what's going on later. Okay, so that's a whole giant pile of C code. Sorry, not sorry. But we learned a little bit about what's going on with this, internals of Ruby. We have these objects and our basic objects and values and all this stuff going on. So what happens when we call that string.blank method inside of Ruby? Like, how does Ruby use all of these objects? Well, that's a complicated question, and I'm just going to focus on one specific aspect because I only have an hour up here in total, right? So I can't just go on forever about all of the details. So we're going to look at one particular aspect, and that's how Ruby manages memory in this instance. So I have this file called mem.rb. That's right, because I'm in the wrong directory now. See, I told you we're going to have fun with me screwing up live coding a bunch. Before I dig into the details of m.rb, I want to mention that I stole a bunch of this code from Tenderlove. So he had this example in his blog post, and it's a great function. So this allocatecount function I'm about to explain to you, I didn't really write it. It's Aaron's. Aaron's blog is great. You should read it. So Ruby itself, if you've ever had a problem with your Rails app taking up too much time or too much space, it turns out that the Ruby interpreter actually has a really great set of tools for figuring out what's going on inside your application. And so there's all these really interesting things that specifically let you kind of query what is going on in the Ruby interpreter. So you can figure out exactly what's happening. And a lot of that stuff happens in this module called object space. So you can see I have this object space object down here, but you require obj space, not object space, which is an important difference to remember. Excuse me. So one of the things that we can do to think about the memory that our objects will take is, we can look at the definitions of things and figure out the size. So what we could do is is we could say, okay, so an R object has an R basic inside of it, and we already said that R basic has a value and another value, and because I'm on a 64-bit system and a value is a pointer, that means that there's going to be 8 bytes for each of the pointers, or maybe not. I always get this math wrong. And then, okay, so we have the 16 for that one, and then the union is this long or whatever. All that math is like far too complicated. Like, this is why we have computers, right? Like, I don't want to have to manually calculate how much memory this takes. I want to have a computer do it for me. So object space has this really convenient function called memSizeOf, and you can pass it any Ruby object, and it will tell you how much memory that Ruby object is currently using, which is really cool. So in this particular script, I say object size, and then I take the size of a Ruby object and then print it out. So that'll be the first bit of output we'll see. Then there's this function called allocatecount. I'm going to do the rest of it first and then explain what allocatecount does at the end, because it's kind of cool, but I'd rather just skip it for the moment. It figures out how much memory we're going to use in a block of Ruby code, to give you that example. So, so here now we call the allocatecount method and we pass it in, okay, let's match this regular expression against this string, and allocatecount will analyze that. It will figure out exactly how many things that we allocated and return that as a hash. So we assign that to this hash counts, and then I'm going to manipulate that hash a little bit. So there's 2 particular keys. One is called free and one is called total. And those are sort of metadata about what's going on. They're going to mess up my math, so I'm just going to delete those keys entirely. We don't care about those 2 things. And then to make the printing a little bit better, so this hash, this counts, will return the kinds of Ruby objects that we made and then the number of them that exist. So if we don't have any of them, it will give us a 0, but then we'll have a huge list of objects. So I'm just going to go through this hash and delete all the ones where the count is 0. So we're just going to eliminate all the ones that we didn't allocate. And so then we'll print that hash out, and then we'll do some math. And the math is basically, we're going to sum up the number of those objects. Why is it times 40? That's what the value of size is. Man, I told you, like live coding, it's just going to get screwed up. Let's change this script and see if it still runs afterwards. So this will take the size and multiply it times the number of objects, and we'll see exactly how many there are. Now, this is an approximation because technically I should be figuring out the size of each kind of object and then multiplying them together, but for my purposes that doesn't matter this much. So if we run this, it says, okay, so a brand new Ruby object is 40 bytes of memory. Running that regular expression match will create 54 strings, 1 hash, and an imemo. I'm not 100% sure what an imemo does, but I think it has something to do with Ruby's GC. This is the fun thing about like messing around with stuff, is you don't have to know everything. You can just kind of like learn more as you go. So if we take those 40 out, if we take those 54, 55, 56 objects that we allocated, and they take 40 bytes each, we end up with 2240 bytes of memory that are allocated. So we're going to talk more in a minute about like why we care about these 2240 bytes. But first, briefly, what allocatecount does, because I think it's really cool. So did you know Ruby actually has a GC class, and it lets you mess with the garbage collector inside your Ruby program? So you can call gc.disable and gc.enable to pause the garbage collector and then turn it back on again. And this is really useful when you want to do this kind of analysis. So what this allocatecount function does is it disables the garbage collection, and then it uses this count objects method to get a count of every single kind of object that is currently in the Ruby interpreter. So how many objects do we have in total? Then it calls the block of code that we gave it with yield, and then it counts the objects again into after, and then it goes through and it deletes the number before and after to give you the amount that would be generated during the run of that function. And then it turns the GC back on, and then it returns those values. This is kind of this neat little helper function, but it also shows you how, even if you don't want to dive into the C code, you can do all kinds of poking around in the Ruby interpreter by using the object space and GC classes in Ruby. And I think that they're really underappreciated by most Ruby programmers, and they're really cool. So you should check out the documentation and like mess around with them, because I think they're really neat. Okay, so we got these 2240 bytes of memory that Ruby is using whenever we do this kind of match. And that's not a lot of memory, and Ruby's using JE-malloc by default, which is a very fast memory allocator, and the garbage collector is pretty fast at allocating memory. It's got all sorts of sophisticated techniques for reusing memory, so it doesn't have to call the operating system every time. So that's not necessarily a problem. But let's talk about what happens in the Rust version. So Rust, unlike Ruby, does not have a garbage collector, and so it's more like C in the sense that it lets you control exactly how much memory all of the things that you have are using. And so what that means is that chars iterator, when we called chars on the string in Ruby, it returns the type char in Rust, which is always 4 bytes of memory. And then those go away after every iteration of the loop. So we're only using 4 bytes of memory every time we loop through with those strings. And then it turns out that the closure, because it doesn't capture any variables, it also goes away to absolutely nothing. And then inside that other function, there's also not that much more memory. So it turns out that we're actually allocating something more like 25 or 30 bytes of memory in Rust for doing the same kind of code. So what being able to reason about these things lets us do, in a more low-level language is that we can do all these optimizations by knowing, okay, we're going to use a whole lot less memory, and that means your program is going to run a whole lot faster. There's also this thing called stack versus heap allocation, which you don't have to worry about in Ruby at all, but you'll have to learn if you start messing with C or messing with the Ruby internals. And I'm not going to go into that right now, but I wanted to mention that this also makes this question a little more complicated than just simply like how much memory are you allocating. So let's talk about C and Ruby together. So you may have heard of this gem Fast Blank by Sam Saffron. And let's see if the internet is working or not. I think that it might be. Yeah. So Sam wrote this gem called Fast Blank. It turns out that regular expression implementation of blank in Rails was actually a bottleneck for their web application, Discourse. So they rewrote a version of it in C instead. So you remember that we had that beautiful Ruby one-liner. Here is what the C extension looks like. So it's got all of this. Yeah. And so the reason why is all this stuff is matching all the Unicode values for the same thing that alpha thing did in Ruby. So when Matt says Ruby is about making programmers happy, the reason that Ruby makes me happy is because I can write that regular expression match instead of this giant case switch statement, right? But the thing is if you look at the the README, Sam talks about how much faster is faster, and it turns out this is 1.2 to 20 times faster than active support, depending on how the stars align and how that stuff goes together. So there is some kind of benefit for writing this in a low-level language if this is a bottleneck in your application. And part of what like the philosophy of Ruby says that computers are getting faster all the time, so we don't have to worry about how fast programs are, but sometimes we do. Like, most of the time it doesn't matter, but, maybe you want to save money on your EC2 bill, or, maybe, you can't spend any more money on your EC2 bill because your company's going to go out of business. I used to work for a startup in Silicon Valley, and I don't anymore. So, things go out of business all the time. So what's interesting is, though, I showed you about how all that, there's that big switch statement, like 100 lines of C code. It turns out that this one-liner of Rust code is actually as fast, if not slightly faster, than that C code. So the cool thing about Rust is you get to write this code that feels more like Ruby. There's a lot more punctuation, mind you, and this is a simple example, and it does get trickier. But my point is that like the reason that I like Rust is that it brings that Ruby philosophy of happiness to low-level programming for me. So that's something I think is really cool. Yeah. Anyway, let's not tempt the internet anymore. So one of the other cool things, so C extensions in Ruby, Ruby knows how to talk to C, and what's cool is Rust can impersonate C, so you can write extensions to Ruby in Rust that pretend they're C, and then Ruby loads them and thinks it's C, and now you have a C extension written in Rust instead of in C. So this is really cool. There's a number of companies that are doing this in actual production, and it's neat stuff. So I think I have a couple minutes. Let me check my time real quick. I do. So I'm going to show you a couple brief ways on how to do this. I've actually given full-length talks on this topic, so I'm not going to repeat all of that stuff. But you can also look at those if this is something that interests you, because it turns out there's like 9 different ways to make this happen, depending on how interested you are in different things. Okay, so no, I forgot source. Okay, so in this particular case, I happen to have this directory, and I'm going to go into the Rust directory. And in Rust world, we have a project called Cargo, and Yehuda wrote it. It's basically bundler for Rust instead. So the tooling is very similar. You write a cargo.toml, which is the same as your gem file, and inside of it, you have dependencies and the versions they depend on, and then it just handles downloading and installing all these things. So this is a Rust project that does basically nothing. There's a bunch of really complicated this is, again, I like messing around with stuff, so I'm not going to say this is the best Rust code in the world or the most practical Rust code in the world, but here is a function called num. So in this case, we say pub extern C function to make Rust pretend that it's exposing a C function instead, and it returns a 32-bit number 5. We also need this no mangle annotation as well. Those two things, extern C and no mangle, is what lets Rust pretend to be C. Then it turns out the other part of this that matters is this Rust example init. So when you write a C extension in Ruby, it requires that there is a function named the name of your project underscore init, and it runs that function whenever you load up your library. So fundamentally here, I'm not going to ignore those other functions, but here I just have a Rust function returning the number 5. It's not complicated, but this is a demo. Obviously, you can do more complicated things than that. I have a couple of different examples of actually using this thing. The one I'm going to show you is Ruru. So there's this project in Rust called Ruru, and what it lets you do is it lets you import Ruby. So it's called Ruru for Rust in Ruby. It's actually authored by a guy from Ukraine. And it lets you define Ruby classes in Rust instead. So like we could write a C extension that loads up that 5, but we can also define Ruby classes within Rust by using this FFI in the other direction as well. So here's a class called calculator, and it has a method called pow3, and it uses a Rust hash, loops through all the numbers, and then stores the number and then the power of 3 of that number in the hash, and then returns it. So here, it also has that init function, like I said before, and it makes a new calculator and defines the pow3 method on it. So one of the things that we can do is we can then, I named it libruru lol because the ruru was the name of the dependency, and I needed a good name, and I just typed in whatever came into my head, so it's named libruru lol. But when we require relative this Rust file, it actually will generate a Ruby class named calculator with a pow3 function. And so this is a Ruby script. I can run ruby example.rb, and it will print out 1 to 5 with these pals. So we've like defined a Ruby class entirely in Rust, and then exposed it to your to your Ruby project. So this is a really cool thing. The last one I have is this Rails example. So it's in the controllers here, welcome controller. So I have this controller in this Rails app, and it requires this Rust example project. And then it says, OK, give me a number, and puts in an instance variable. And then in the views directory, the index just prints out get a number from Rust. The number is number. And that require is in the lib directory. So there's this really, really great package in Ruby's standard library called Fiddle. And Fiddle lets you just open up C libraries inside of your Ruby code and then link them to Ruby. So this is like a totally different way than Ruru. But what this does is this loads up that first example I showed you with the 5 and binds the num method to it. And it says it takes no arguments and returns an integer. Fiddle is a very complicated library. Again, this isn't a demo about Fiddle, but you should check it out because it's really cool. And then it will call that function. So if I load up, oh, it's Rails S. you would think I have commit to this project and I could remember how to type it. So this is an extremely elaborate way to print the number 5 on the screen from inside your Rails app. But we have a Rails application loading a Ruby library that loads what it thinks is a C library that's actually a Rust file that gives a 5, and then it prints it. So, yeah. The last one that I'm going to show you is this mrusty project. And this is really cool because, wait, I don't want this one. I want this one. So mrusty is a package for Rust that includes mruby. So it lets you embed mruby inside of a Rust program. So Matt was talking earlier about how mruby is embeddable during the questions. That actually does this. So if we look at the examples, this is a Rust program that loads up the mrusty package, and then it uses a bunch of the functions from that package. Let mruby equals mruby.new. You can think of this as like making an mruby interpreter as an object in your program. So you're like, give me a new interpreter, and it just makes one. And then you can define classes in Rust. So here's like a thing that lets you just store a number inside of this container. And then we can say mruby.run and write Ruby code in a string and then pass it to the run function, and it will just run that Ruby code inside of the mruby interpreter and print stuff out. So then this prints the value 3 because we require the container, and then we add 3 and whatever. So cargo run example container. Oh, I thought I had built this before. I think I passed the release flag. You can see this is like the bundle install equivalent, right? It's just like download a whole bunch of stuff and it installs, and then you get warnings. This is like, Nokogiri giving you warnings about not working. So yeah, so we got 3. So we embedded a full mruby interpreter into a Rust program and then spit out a number 3. Okay, so that's all for the demos about that gem stuff. Like I said, I've done a whole bunch of other talks and documentation about how all this stuff works. You can learn more about it later. I mostly just wanted to show you that stuff real quick. And people are actually using this in production today. So you could write a Ruby gem in Rust, and some people already have, and they're used it in their businesses. But just yesterday or the day before, I was on planes a lot. My time zones are totally screwed up. On the 19th, whenever that was, sometime in the recent past, this company called Sentry wrote a Python package in Rust instead. So we'll just pretend I said Ruby instead of Python because the principle is the same. But they wrote this blog post you might want to check out called Fixing Python Performance with Rust. And what they do at Sentry is not super important, but what they were doing is they were loading up JavaScript source maps and processing them and spitting them out. And they wrote the original version in Python, and it was a little too slow, so they rewrote a version in Rust instead. And this is the graph of their CPU time on their servers as they deployed the Rust version into production. So they had all of this, high-level memory usage, and then it dropped down significantly. And it was actually a significant enough drop that you can see the overall processing time for the application went down, like across the board, because it turns out those slow requests were like a lot of their significant slowness. So if you have a similar kind of heavyweight processing task that your Rails app needs to do, you could theoretically write that in Rust instead of in C. And so I think you should check that out. I know that my very first Rails app, so I started programming in Rails with Rails 2.3.5, and I learned like the first week after that it had a security vulnerability, so I upgraded to 2.3.6 right away. That was for a startup that I started a very long time ago, and I had to write a C extension to do this kind of thing in my very first Rails app. So, it happens more often than you'd think. The other funny thing is after that company went under, I put it in a zip file and I saved it on a hard drive, and I haven't looked at it since. So I think I'm going to give it another like 2 or 3 years and then go look at my first ever Rails app and be like, oh God, I was so bad at Rails. What am I doing? So I have that saved as like a time capsule for me. But okay, so I said this talk wasn't going to be about serious stuff, but then I'm like, garbage collectors and look at the C code and all this stuff that's like a little more intense than maybe you were expecting. So I do have something that's ridiculously silly that I haven't really shown anyone yet. You might have seen me tweet about it a couple months ago, but I wanted to prepare it to give this talk. And so I want to show you a really ridiculous, silly thing that does not It doesn't matter at all, but it's lots of fun. And I think this is really important. Like, one of the things that we've sort of, Sean mentioned this morning that like Rails is growing up and becoming more mature, and it's been happening over the last couple years, and that's good. But I think that, you know, programming is about having fun and joy as well as making your rent check. And so we have lots of conference talks about how to like do a better job of engineering, but we don't have a lot of conference talks about doing really dumb stuff just for the heck of it. Like, you know, or just trying stuff out. So I wanted to share with you my latest silly hack. It's a side project of mine, and that is I have a fork of Ruby. It's a new version of Ruby. Forks. It has 4 commits, so I've clearly been working on it very hard. And let me show you what's in those 4 commits if I can remember the right key combination to make this happen. Yeah, okay. It's right here. So here's Steve's Ruby. First of all, you notice can't automatically merge. This patch is never going to go upstream. I can guarantee you that it won't ever happen. But what's cool about that is it means I can do tons of terrible things, and it's fine because no one's going to see except for I'm showing all of you. So all of this does is, so you see 592 additions, 8 deletions. So when you download Ruby, so let's go to here's a copy of my checkout in Ruby. So it's a very common thing that you do in Unix is this. So we have this thing called makefiles, and makefiles run the compiler to build the different stuff in your program. But as things got more complicated, eventually people were like, these makefiles are getting far too complex. So what did we do? We threw more programming at it. And that's when we came up with this convention called configure. So a configure script is a script that would analyze all the stuff that's on your computer, and it would generate a makefile for you. And then you would run that makefile. So this is typing like /configure make, if you've ever seen that in Homebrew, or if you've ever typed that yourself, if you've compiled programs from source. So the problem was, it turns out that wasn't complicated / good enough. So then we invented this tool called AutoTools. And what that lets you do is it lets you write a programming language to describe what you would like the configure script to look like. And then the configure script generates the makefile from that. So we're generating files that generate files. And that's really good. And Ruby uses that system. So if you want to compile Ruby, this is a fresh checkout of the Ruby interpreter. Well, I mean fresh when I started this thing, which was like a month or 2 ago. But you type autoconf, I forgot the O, autoconf, and then this will run, and it generates a /configure file, which you then run, and it checks all this stuff and prints all these things out. If you've ever like installed Linux and like felt like a hacker, you're like, oh, I totally know what's going on here. I remember being like a 14-year-old kid and like getting Linux for the first time and watching all this fly by, and I was like, yeah, I'm so good at computers, when like literally I just typed /configure. So those will go through, and this will do all this stuff, and then that generates makefiles. I'm not going to let you. Oh, it finished. Cool. I was like, if this isn't done in a second, I'm just going to kill it. But it generates a makefile, and so suitably speaking, Ruby has then put the makefile into its gitignore file. So the first thing I did was commit this generated makefile to version control, because this is only about my computer. I'm never sending this patch up in the future. It doesn't matter. So here's what that makefile looks like after configure generates it. And so that needs to be in there. And the reason that it needs to be in there is these last couple of lines. So what I actually did in this fork of Ruby was I removed one single function. It's not even a full Ruby method. It's just one function that's used inside of array, and I rewrote it in Rust instead of in C. So it's like the old Ruby array.c file, I now also make an array.rs file, and then I compile them together into one final thing. And because it has the same name as the way that the original array file is generated, the rest of Ruby's build system is just like, cool, I don't care, and it works. But figuring out how autoconf generates the configure file that generates the makefile was like too much work. So what I did was I just committed the makefile and I added some rules to the bottom, because like figuring out how to make it work all together was just far too much. And this is part of what I mean by like when you're doing fun, silly hacks, you don't have to worry about it. If this was a patch that I was thinking about actually sending into the Ruby interpreter for real, I would have to figure out all that mess. But because this is just for fun on weekends, I don't have to care. I can just do this terrible thing. And so first of all, what this does is it says, hey, for array.c, do nothing. So just don't compile that file. And then for array.o, which is the output file, I made a Ruby array.c and an R array.rs, because I was like, again, they both start with R. I was like, wait, I can't call one the Rust array and one the C array. So I compile the Rust array.rs file, and then I compile using the same exact line that it does to compile the original C. I compile the original C file together. And I just literally, whoop, I clicked over. I copied and pasted this from elsewhere in the make file. Like I know what this does, but like I didn't like come up with it or something. I was just like, oh, that's how it compiles the file. Yep, copy and paste that line, paste it down the bottom. It's fine. And there's a tool called LD that you can use to link two separate files together. So I link the Ruby portion that has all the real code in it, and then the Rust part that has the one function in it, and I linked them together into an array.o. And then because all the rest of the Ruby build system knows what to do with array.o, that's all I have to tweak. So, so I messed with that. And then here is the example of, it's a 3-line function. I told you this is a very trivial change. Because I just wanted to see if I could do it. So I was like, what's a small function that does something real? So inside of array, there's this function called rbmemclear. And what it does is it takes a particular chunk of memory and it sets every bit of that chunk of memory to be nil. So here, let me make this a little bit bigger. So this is some C code. You have this function, and it takes these two arguments, mem and size, and then while size minus minus. So this is I'm going to criticize this code slightly, but not because it is bad C code. It's because it's C code, and C code is often bad from the perspective of other languages. So this is good C code, but it uses a pattern that I think is bad. But if I was writing C, I would write this exact same code, because this is what you're supposed to write when you're writing C. So while size minus minus, you notice there's no comparison here or whatever. That's because it's actually until size is false and 0 is false in C. So if the size is, you subtract 1 every single time, when it goes down to 0, it will end. The problem is that you can't guarantee that this is a positive number. So the reason that I don't like this idiom is because if size is negative, it'll just go infinitely forever and just overwrite all kinds of memory with stuff. That happens. But we loop while the size is greater than 0, and then this is another idiom that's classic in C. So we say, okay, this memory is a pointer to a chunk of memory, so we dereference it with the asterisk. So we're saying, hey, we're going to put something in here, and that something in here is called qnil, and qnil is what Ruby calls nil inside the C code. And so then the ++ increments the value of the pointer after we do the assignment, but not before. And you have to memorize that rule about the C code. So unfortunately, I'm out of time, so I can't show you how the 3 lines of Rust is clearly superior to the 3 lines of C. But my point is that hacks are fun, and you should mess around with Ruby interpreters, all of them, because it will teach you more about how Ruby works. So thank you again so much for having me, and go forth and do fun stuff.
Thank you. Вопросы, пожалуйста.
Thank you so much.
Hi, Steve.
Hello.
It's nice to hear you at this conference, and I have a question about the most scary thing in Rust, as I think, and it's learning curve. So, what do you recommend to newbies, step by step? What concepts of Rust you should learn step by step to be a successful Rustist and live without that annoying idea to kill yourself every evening? About another session of code work on a Rust field. Thank you so much.
So I'm a little biased with this answer. So the question is like, how do you get good at Rust? So I wrote a book on Rust that's distributed on the website, and it's fine, but I'm critical of my own work, so I'm rewriting the book, so it'll be even better the second time. So I have an in-progress book that you should check out. But it's easy to say, just like read the thing I wrote and then you'll be good at Rust, because, of course I wouldn't do a bad job. Obviously, I'm not going to say that about myself. But what I did and how I learned it was I hung out in the IRC channel and I just listened to people ask questions. So what happened was I didn't know any Rust at all. I started just messing around with things. I read the documentation. I wrote some small programs. And then I sat in IRC and someone would ask a question. And I'm like, not only do I not know the answer, I don't know what this question even means. But then, you learn small stuff over time. And eventually I was like, I know what the question means, but I don't know the answer. And then after a lot longer, it's like, now I know the answer to this question, and by now I know the answer to like almost all the questions. So that doesn't mean you should literally sit in the IRC room, although we would love to have anyone that wants to do that. But I think that learning a programming language is sort of a long practice over time. So if you try to write some small programs and see how they go, don't be afraid to ask for help, because we in the Rust world love to help new people. I think taking it in small chunks and then just practicing is the best way to get better. There are definitely some complicated features in Rust, but what's lucky is you don't really need to use them until you're doing something complicated. So the easy stuff is easy and the complicated stuff is complicated. So that would be the advice I would give you. Yes, check out the book, try to write some code, ask questions, and practice, basically.
One more question.
One more.
Hi, I'm here.
Hello.
When you show us Rust example, there is a function that called isWhitespace.
Yes.
Can you explain what it does in Rust?
Yeah, so we have it built into the standard library, and it does the same sort of thing that C code did with the big giant switch case. It's just implemented for you already. It's not the exact same code because we, instead of hard coding the numbers, we look up in the Unicode tables what the white space names of the Unicode stuff is, but it implements basically the same thing. It just happens to be in the standard library because all Rust strings are UTF-8, and so we have a bunch of Unicode stuff built in because by starting a new programming language, we're lucky enough to just say everything is UTF-8 and not have to worry. If you remember the Ruby 1.8 to 1.9 transition, it was like really complicated, right? So, but that's what it does. It's the same thing as the regular expression or the switch case does.
Oh, okay. And where can we see its lines?
I will tweet a link to it, but they're actually on my GitHub as like I was pushing to them earlier this morning. So you'll see the like new activity if you just look at my GitHub.
Thank you.
Thanks so much, everyone. I think. Oh, you got one more, or is it? All right, last one.
Oh, thank you, Steve, for your presentation. That really was great about hacks using Rust, but I have a question about, we have a really huge field, programming field. For example, if you do data science, you may probably use Python. If you do, for example, game dev, probably you use C++. And the main question for me is, what's field one took the Rust? I mean, one took, yes, the Rust.
So I think that there's two answers to that question. I will keep it brief. The first one is wherever you would use C or C++, those fields are what we're trying to get into. So the game development community has good things. Anything that needs sort of speed, high performance computing. There's actually 3 programming languages written in Rust now. But the thing that we're focusing on trying to make better right now is actually Rust on the server, so web frameworks in Rust. The first Rust conference was a couple weeks ago, and there was a keynote talk about the new asynchronous I/O that we're getting in Rust. And the web server we built with it is the fastest web server in the benchmark that we ran, period, of any programming language. So we think that really high performance web stuff might be a future where Rust finds a niche. And as web applications grow, you need better performance. So pretty much, where performance matters is usually, I think, where we're going with Rust. Cool.
Steve, thank you.
Thanks.